Hello, Chem 2 students. This is Mr. Keister here with you again. This is the video for Thursday, September 3rd, which is our scheduled 11th day of school for the fall semester. Keep in mind, though, I've got to give you my disclaimer. The dates could change on these lessons for a variety of reasons, but regardless of that, the lessons will continue in the same order regardless of that. So let's take a look back at our do-nows and our daily schedule for today. So today you're to pick up page 21, conversion factors and dimensional analysis. We're going to start doing conversions today. Yesterday we did lab 1-1, basic, lab 1-2, which is density and specific gravity. That is due now, so make sure that you turn that in. Of course, if you're at home, you'll be submitting that to me electronically. I made a note here. Now, I provided you with the answer key either here or online on my answer keys page, but I made a note here. Did you properly record all your data to the correct precision level? Did you make sure that you were aware of what the smallest marking was on each of your measuring devices and that you then rounded those measurements accordingly? Did you show all equations when you did your calculations? Did you write the equation down? Did you plug the numbers in? Did you then calculate your final answer and label and round it correctly? Make sure that you did that, and also make sure that all of your numbers within your lab group match exactly, all right? Exactly. If not, there will be a deduction for that for all group members, okay? So today in class, we're going to go over how to do conversions using conversion factors and dimensional analysis. There will be an assignment over this that is due tomorrow. So let me pull up the notes and we will continue. All right, so back in Chem 1, we did quite a few conversions. The conversion method of choice in Chem 1 was proportional reasoning, which we are going to do tomorrow. I'm going to show you how to do this dimensionally using conversion factors, simply because when you do proportional reasoning, especially on those problems that require multiple steps, rather than having to set up multiple proportions and solve for multiple answers, using this method, we can do things all at once, all at one step. And in Chem 2, we're going to solve a lot more complex problems whereby the conversions are going to be much longer. And so for that, this particular method seems to work out the best. So this is the method of choice in upper level chemistry classes. This is the method of choice that you will see in your college classes. So dimensional analysis is a method of doing conversions and or analyzing and solving chemistry problems using conversion factors. Conversion factor is a ratio of equal measurements. The ratio of the numerator to the denominator in any conversion factor is always equal to 1. So I've got some examples here on the board. Let me flip that over a little bit. There we go. These, of course, these first two are just fractions, right? 1 over 1 and 29/85 over 29/85. Of course, if the numerator and denominator are numerically the same, then of course they have a value of 1. But now these four here, the numerical value of the numerator and denominator is different. However, when you put the proper unit with each one, now all of a sudden they are equal, all right? So they do have a value of 1. 100 centimeters and a meter, as we have learned recently, or relearned recently, are equal in value, all right? They're equal in value. They're equal in value. If you divide one by the other, the value is 1, okay? A minute and 60 seconds have the same value. A kilogram and 1,000 grams have the same value. 1 inch and 2.54 centimeters represent the same length, all right? So all of these conversion factors here overall have a value of 1, since the value of the numerator and the denominator are equal. So to solve conversions using dimensional analysis, what units am I starting with? What units do I want to end with? And then how do I get there? All right. So let me advance the page here. We will talk about that. Here's how you start. You start with your given measurement as the numerator with the denominator being 1. So just take what you're given, put it over 1. Use conversion factors to get from the units you're starting with to the units you need, with each units in the conversion factor being placed appropriately, either up above in the numerator or down below in the denominator, so that they cancel out. Use multiplication between each conversion factor. When you reach the desired units for the answer, you know when to stop. All the other units should be canceled out. Okay? So let's run through quite a few examples here, and let's do that. So the first one, using dimensional analysis, convert 14.9 minutes to seconds. All right. So we're going to take our original measure, our original info, 14.9 minutes, and put it over 1. All right. Then we're going to find a conversion factor that relates minutes and seconds. Well, I think you probably know that. There are 60 seconds in a minute. Now, we're going to want to place the minutes so that they cancel out. So I'll put the 1 minute down here. Since these units are on opposite sides of the dividing line, of course, they will cancel. We'll put the 60 seconds up here. Okay? Well, we're looking for seconds, and that's the unit we already have, so that means we have no more steps. All right? So now you multiply, see the times there. Multiply these. So 14.9 times 60 divided by 1 times 1, which is of course 1. And we get 14.9 times 60. 894. Now, the question is, how do we round? All right? So here's the deal. As you can see, we got a lot of ones in there, which only have one significant figure, which would then lend you to believe that we round every answer in dimensional analysis to 1 sig fig, because there's going to be a 1 in there at the beginning, and the answer to that is no. All right? Standards and ones are not included. And by standards, I mean constants in sig fig determination. All right? So if they're not included in sig fig determination, what is? Well, it's right here. Sig figs determined by original measurement. All right? So our original measurement is 14.9 minutes. That's 3 sig figs. The actual mathematical answer to this is 894 seconds, which also has 3 sig figs. So for this particular one, we don't need to do anything around this 894 at all. It's already in the same correct number of sig figs. So that is indeed our answer. Okay, 894. All right, next. Little note here. There we go. All right, using dimensional analysis, convert 175 pounds to kilograms. So this is a metric to English conversion. We don't probably all know what those are, so I listed that here for you. A kilogram is equal to 2.20 pounds. All right, so we're going to start with our beginning measurement, 175 pounds, put it over 1, and we're going to convert pounds to kilograms. So we need the pounds on the bottom, so they cancel, the kilograms on the top. So 2.2 pounds, here's our conversion factor, is equivalent to 1 kilogram. All right, so kilograms is here, kilograms is what we want, no more steps required. So 175 times 1 is 175, 1 times 2.20 is 2.20, so we're just going to take 175 divided by 2.20. Based on this right here, and then when I do that, just to give you the long answer, is 79.545454 ... All right. Based on the fact that our original measurement has 3 sig figs, we will round this answer to 3, same. And so that would be, in this case, 79.5 kilograms. 3 sig figs. Okay? Let's go to the next one. Using dimensional analysis, convert a mass of 14.0 grams to volume. According to Silver's density, a centimeter cubed is equal to 10.5 grams. In other words, Silver's density is 10.5 grams per centimeters cubed. Keep in mind, some of you are probably asking us, hey, wait a minute, we can solve this using D equals M over V. Yes, you could. You certainly could. But I want to show you that you can also solve this problem dimensionally, all right, using dimensional analysis. So, because it may come in handy sometimes. I want to show you how to do that. So we're going to start with our beginning information, 14.0 grams over 1. And now we're going to use Silver's density as a conversion factor. Well, again, I want grams on the bottom so that they cancel. Centimeters cubed on the top. Plug in the numbers from the density there. And now we have centimeters cubed, which is a measure of volume. That's all we need to do. So it'll be 14 over 10.5. And the long answer is 1.33333 repeating. All right, well, based on our original measurement, 14.0 grams, the conversion factor is Silver's density, which is a constant that is not used to determine sig figs. Our original measurement, although it's still 3, doesn't really matter how many it is. This is what we go by, the 14.0. So 3 sig figs then would be 1.33 centimeters cubed. 1.33. All right, those are some simple ones. Not very many steps, just a couple. But let's look at some that may be or some little different ones. In many conversions, it's important that you know your metric conversions in terms of conversion factors rather than just being able to move the decimal. So we've already learned how to do metric conversions by knowing the placement of the prefixes on the metric conversion line or on the metric line, and then just moving the decimal. You can also use the metric line to determine conversion factors of metric measurements, and I'm going to show you that here now. Here are the steps. Starting out normally, put your beginning measurement over 1. For your conversion factor, put the correct unit in both the numerator and denominator. In other words, we want to cancel the 1 out and get to the other one. Here's the key. Whichever unit is larger, we're talking about our metric conversion now, gets the 1 only. The smaller one gets a 1 followed by an appropriate number of zeros, which is determined by the number of spaces between the units on the metric line. All right? So we're going to use the metric line just like we had before, only now we're going to use it a little different way. It's very handy that way. All right, so let me advance this up so you can see it better. And we'll do a couple. And I'm going to star number 3 here. We'll come back to that in a second. So using dimensional analysis, convert 145 grams to grams. Again, I know you could do this by just moving the decimal, and that's fine, but I want you to see how to do it dimensionally, because that could be very handy in some multiple step problems where only one of the conversion factors is the metric one. All right? This is why this is handy to be able to do it this way. So we'll start with 145 grams, put it over 1, just like before. We're going to, milligrams. We're going to convert to grams. So we want milligrams on bottom, grams on top, so those cancel. Now, let's go to this right here. Whichever unit is larger. Which is larger, grams or milligrams? So visualize the metric conversion line. Grams is the base, right? Milligrams is over here, 3 spots away. All right, so mill is this way. Remember, they're getting smaller going this way. So grams is bigger. All right, grams is bigger, it gets the 1. Milligrams is smaller, it gets a 1 followed by an appropriate number of zeros. Well, we just said milli is 3 spots away from base. 3 spots, 3 zeros. 1,000. There are 1,000 milligrams in a gram. Okay? 145 divided by 1,000 is 0.145 grams. Okay? And had you said, well, if I'd just moved the decimal 3 places to the left, milligram to gram, I'd have got the same answer. You're right. You should get the same answer. All right? But I want you to see how to do it this way. Okay? Because you'll need it. 7, using dimensional analysis, convert 0.073 centimeters to micrometers. All right? And again, this is 3 sig figs, same as that. Forgot to mention that. So we have 0.073 centimeters over 1. We're going to convert it to micrometers. Centimeters down here, so they cancel. Micrometers up top. Okay, so which one's bigger? Visualize again. So here's where you're going to have metric line memorized. All right, so here's base. Cent is here. Micro's down here. So cent is to the left of micro, it's bigger. All right, so centimeter gets the 1. How far apart are they? Okay, so base, milli, here's centa. Then you've got milli, 4, 5, micro. It's 4 spots away, all right? 4 spots away, 4 zeros. 10,000. 10,000, right? A 1 and 4 zeros, 10,000. So 0.073 times 10,000 is 730 micrometers. This has 2 sig figs. Remember that 0 is a placeholder. That 0 is a placeholder as well. This also has 2 sig figs. That's correct. Okay? So you see how to do metric conversions using dimensional analysis. All right? The larger of the 2 metric units gets the 1. The smaller gets a 1 plus an appropriate number of zeros. That number of zeros is determined by the number of spaces apart the 2 prefixes are. Okay? All right. Advance the page. Here are some multi-step ones. All right? Multiple step. Using dimensional analysis, convert 1.00 days to seconds. All right? 1.00 days to seconds. All right, so let's start with a day. What do you know? Maybe some of you know how many seconds are in a day. That'd be great. But if you don't, we're going to figure it out real quick. What do you know about a day? Well, there's 24 hours in a day. I know that one. Well, let's use that. So the day go down here, the hours up here. 1 day is 24 hours. Days cancel. What do you know about an hour? Know anything about an hour? Well, there's 60 minutes in an hour. Let's use that. So the hours down here, the minutes up here. 1 hour is 60 minutes. Hours cancel. Now we need to know seconds. You know anything about minutes and seconds? Sure you do. There's 60 seconds in a minute. All right? So the minute down here, the seconds up here. The minutes cancel. In 1 minute, there are 60 seconds. So we got more steps here. Here's the seconds. That's what we're trying to find. So we got it. So we got 1 times 24 times 60 times 60. Those are all 1s. 3 sig figs. When I do the math, the actual answer actually comes out 3 sig figs. So we don't have to do any rounding here. It's 86,400 seconds, which is 3 sig figs. So now, maybe you remember that number now. There are 86,400 seconds in 1 day. Well, now you know another conversion factor. There are 86,400 seconds in 1 day. That comes up on a homework or a test or review or mastering or whatever. Sure, you can get from days to seconds using these extra steps, but now that you know that, why not just use one step? 1 day is 86,400 seconds. Now that you know it, may as well use it. It'll save you some steps and some time. Okay? All right. Number 9. Convert 2.50 tons to kilograms. All right? Gives us some conversion factors here we can use, so we'll use those. Again, this is English to metric, so you may not know all that. So we'll start with what we're given, 2.50 tons, put it over 1. This one you probably know, there's 2,000 pounds in a ton, let's use that. So ton down here, pounds up here, 1 ton is 2,000 pounds, tons are out. Pounds to kilograms, there's where we're going to use that one. All right, so the pounds down here, the kilograms up here. There are 2.20 pounds in 1 kilogram. Pounds cancel. We're left with kilograms. Let's do the math on that one. 2.50 times 2,000 divided by 2.20. All right, I get 2272.7272 repeating. All right. Well, how many sig figs we gonna need? I'll write that over here. So it's 2272.7272 ... Okay. Well, our original measurement has 3 sig figs. All right. So this answer needs to have 3 sig figs. Well, there's 1, 2, 3, 227. But we got the ones place yet. What's got to go in there? Got to hold the place. That's if you said a placeholder 0, you're absolutely right. That's what they're used for. So to 3 sig figs, this would be 2,270 kilograms. Good little practice there on sig figs and placeholder zeros. Very necessary. You can't round 2,272 down to 227. That sounds kind of silly. It is, all right? That's what that placeholder 0 is for. It's not significant, but it sure is important, all right? All right. Some measurements are expressed as a ratio of 2 units. These are called complex units. Density, we've already looked at, all right? Density is a complex unit. That's actually the density of aluminum, 2.70 grams per ml, all right? Speed is a complex unit. It's a unit of distance over time. Molar mass, remember that? That is a complex unit. It's the unit of mass in grams over moles, all right? So these are complex units. What I want you to understand is how can these be expressed as a conversion factor? Well, I think you probably already know this. If you're going a speed of 88 kilometers or kilometers per hour, you're going a distance of 88 kilometers in how many hours? 1, all right? If the density of aluminum is 2.70 grams per ml, that means there's 2.70 grams in how many mLs? 1. If the molar mass, that's actually the molar mass of water. If the molar mass of water is 18 grams per mole, that means there are 18 grams in how many moles? 1. Okay? So 88 kilometers per hour expressed as a conversion factor is 88 kilometers over 1 hour. Density expressed as a conversion factor is 2.70 grams over 1 ml. A molar mass expressed as a conversion factor is 18 grams over 1 mole. All right? 1 goes next to the denominator unit. All right? So that's pretty handy to know. So let's do a couple of conversions, dimensional analysis conversions using complex units. Okay? Let me advance the screen here. Got 2 more to go and we'll be done for today. All right. Using dimensional analysis, convert the speed of 65.0 kilometers per hour to meters per second. All right. We do these really the same as any other dimensional analysis conversion, only now we're dealing with 2 conversions at the same time. All right. We want to go from kilometers to meters, and then we also want to go from hours to seconds. So 2 different conversions. Doesn't matter which order you do them in, as long as you get them both done. So let's set this up. We have 65.0 kilometers over, remember, 1 hour. 65 kilometers per hour is 65 kilometers over 1 hour when expressed as a conversion factor. So, you want to do the kilometers conversion first or the hours? Doesn't matter. I usually just start with the top one. So I want to go from kilometers to meters. Kilometers down here, meters up here. Kilometers cancel. Okay, so here's a perfect example of how you need to know to use the metric conversion line for conversion factors. Because here's one where we're going to need it. All right. Remember the rule? Which of the 2 is bigger? Well, meters of base, it's here. Kilometers is over this way. So kilometers is larger. It gets the 1. Meters gets a 1. And how many zeros? How far apart are base and kilo? 3 spots. There are 1,000 meters in a kilometer or kilometer. Okay? Got that one done. Now, we want to go from hours to seconds. All right? Well, maybe you know how many seconds there are in an hour. You know? If you don't, that's okay. We can figure it out real quick. But let's go ahead and, what do we know about hours? Well, we know there's 60 minutes in an hour. We said that a little bit ago. Let's do that. So the hours got to go up here now so that they cancel, and the minutes here. So in an hour, there's 60 minutes. But we need seconds. So we got 1 more to do. So minutes up here, seconds here. There's 60 seconds in a minute. Now, if you said, Mr. Keister, I already knew how many seconds there are in an hour. It's 3,600. It's not 360, by the way. It's 60 times 60, 3,600. And that's found right here. So if you knew that, you could have saved a step here by saying that in 1 hour, there were 3,600 seconds. Could have done that. Would have saved yourself 1 step and a little bit of time. So either way is fine. All right. Either way, let's get the answer. So we had 65 times 1,000 divided by 3,600. And this is 3 sig figs, 65.0. So let me do that real quick. So 65 times 1,000 divided by 3,600. 18.05555 repeating. All right. We need 3 sig figs. So 18.05 would be 18.1 meters per second. 3 sig figs. All right. So, oops, those minutes cancel. So as you can see, we still have meters on the top, which goes there. We still have seconds on the bottom, which goes there. Meters per second. Okay? 1 more. We're done. The daily energy intake of the average American is 2,000.0 kilocalories per day. You probably read in your nutritional guides, wait a minute, Mr. Keister, it's 2,000 calories. 2,000 calories. Well, you might remember this from Chem 1. The food calorie, all right? The food calorie is actually the metric kilocalorie, all right? Kilocalorie. Remember that, all right? The metric calorie is actually 1,000 food calories. All right, or the other way around, I should say. A food calorie is actually 1,000 metric calories. So basically, what I'm saying is, this is a food calorie right here. All right, it's with a capital C, which is actually the metric kilocalorie, which is actually 1,000 metric calories, which is a small c. I don't know if you remember that from Chem 1, but that's probably something important to know. All right, so we want to convert that to calories, the metric calorie per second. So again, we have two conversions to do, kilocalories to calories, days to seconds. All right, so we'll start with what we got here, 2,000.0 kcal over 1 day. So let's do kcals to cals. So the kcal goes down here, calorie here. Okay, remember calorie is a base, kilos over here, so kilos bigger. How much bigger is it? 3 spots, so that would be 1,000, just as we said over there. So 1,000 calories and a kilocalorie. The kilocalories cancel. Now we need to go from days to seconds. Oh, well, a little bit ago, remember we did that kind of long one and figured out how many seconds were in a day? 86,400. Hey, let's use it. Otherwise, we're going to have to do about 3 more steps to get from days to seconds. So let's just use the one and be done with it. So the days go up here, seconds down here. In 1 day, we just determined there are 86,400 seconds. Boy, that saves us some time. See, it's handy to know some of these things. All right, so we're going to take 2,000.0 times 1,000 divided by 86,400. 23.148148 repeating. Well, how many sig figs do we need? Well, take a look at that. A lot of zeros in there. Well, remember, zeros at the end of a number to the right of the decimal are significant. So is that 2, so the 3 zeros in between those are also significant. So we got 5 sig figs. So that answer to 5 sig figs is 23.148 calories per second. 5 sig figs. All right, 23.148 calories per second. So that is converting by dimensional analysis. Very important method that we will use again and again and again throughout this entire course. So you have an assignment to complete over that, and that will be due tomorrow. So that's it for today. This is Mr. Keister signing off. Everybody take care, stay safe, and I will see you next time. So long.